Final pre-talk presentation is on carbon concentration in the atmosphere and snowfall in Boston. So there's a lot of slides, or a lot of graphs in my presentation because this is a very graphical kind of project. And so here in this graph we have carbon dioxide concentration in the atmosphere in February and in January. Something important for the next 3 slides, all air sampling has been taken in Mauna Loa in Hawaii, which is an area in the world that has the purest air. So it's sort of where you might want to get like atmospheric data, if you want it in not the purest form, but like most accurate, essentially. So I broke up the graphs into seasons. Last slide was winter. This is fall. I decided to put December in fall because winter doesn't technically start until December 21st, which is too late in the month to like count it into winter. Yeah. And this is spring. So these all seem very similar. However, they are not the same numbers. This makes sense because, you know, carbon concentration isn't happening at like a random sort of like rate, essentially. It's all happening sort of linearly, which is what these graphs happen to be. These are linear graphs.
Just before can you tell us what the axes are?
Oh yeah, so the axis has changed in terms of these graphs because these are snowfall. But in the last one, on the y-axis, there was carbon concentration so carbon dioxide ppm, which is parts per, I think, millimeter in this case. And then the x-axis was years since 1992 to 2014. So, yeah. And now we're moving into snowfall graphs. So again, these graphs are broken up into seasons. Again, winter, spring, and fall. So these are very random, as you can tell. And I sort of talk about that later on. But in terms of axes on these graphs, y is inches in snow, and then x is, again, years since 1992. So this is the spring sort of graph. There's March and April. And then December. Well, winter, including December. Or no, fall. So this pie chart sort of it shows the distribution of snowfall between the months. I didn't include October in this case because October has only had 2.2 inches of snowfall out of 1,136.9 inches of snowfall. 136.9 inches of snowfall since 1992. And I didn't include it because essentially that's 0% of it, so it would have messed up the graph because it would have added on a different color. But in this case, so you can't see, I'm sure, but 0 is February, 1 is January, 2 is March, 3 is April, 6 is November, or no, 5 is November, and 6 is December. And I was surprised because I live in Boston and I was expecting February to contribute the most snow because it's often the coldest. However, January is the one that contributes the most snow.
Can you tell us the color again? I can't see the color up top, so I don't know what one means.
So this is February, this is January, this is March, this is April, this is November, and this is December. So I got the equations in terms of carbon dioxide concentration from both January and October because I thought since I take the extremes of it, there wouldn't be much, or I could see sort of like the range of how much carbon is distributed into the atmosphere between those sort of like months. So this is essentially, I plugged in points from a table that was helped to make my graph into Wolfram Alpha, and I wanted it to be a linear fit because it seemed like a very linear progression. And so I plugged it into Wolfram Alpha, and the equation I got was 1.7075x plus 355.20, plus 0.235 as my equation in terms of how carbon concentration is sort of affecting the environment. And what's really important in this case is to look at the R2. I forget what R2 really means in English, but it essentially translates into accuracy of the equation. And so this is sort of like graphing out the points that I gave to Wolfram Alpha, and it also graphs the equation that I came up with. So often you're not going to get a perfect equation, and this comes very close to being perfect, which means that this is a very, very linear progression. And can you go on to the next slide? this is October. So this is also a very, 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 very close equation. In fact, it's almost exactly, it's almost exact to what the carbon concentration in January was. So this means that at the worst of the year and at the, like, not the best, but like at the most snowfall of the year and the least snowfall of the year, this equation still remains the same. And I originally thought that as more carbon concentration, as more carbon dioxide there's in the atmosphere, I thought there'd be more snowfall. I'm not sure why. That just was my hypothesis.
30 seconds.
And it's actually not that, because carbon dioxide is a greenhouse gas, which means that there will be less snow, less ice on the Earth, which means snow is an ice or a form of ice, which means that instead of snow, we'll have more rain. These are my sources. Any questions? Yeah, we know.
So in that last slide, yeah, can you shoot like that? 2 seconds.
These are my tables, if anybody wanted to know.
Okay, cool. Okay. Yeah, sorry, I don't know. So on the x-axis is that,
So these are just this. For the y-axis here, it's the carbon concentration ppm. And x-axis is the points that I gave it. So I don't think 0 is 1992, 1 is 1993, 2 is 1994, and then so on and so forth.
so the snowfall increases as the.
Oh no, this is for carbon dioxide concentration. Snowfall decreases.
Oh, okay, that makes more sense. Cool. Okay, thank you.
So that's just showing the increase in carbon dioxide concentration over time.
Mm-hmm.
Okay.
Do you have any predictions that it's gonna keep going like that?
The way I see it, because like there's not much of a focus on sort of preventing the increase of carbon dioxide, I see this sort of like not being an exponential, but like continuously being a linear form. Might this be a sort of like isolated linear part of the parabola? Hopefully, but like as far as I can tell, I don't have enough foresight to say that we're going to end up decreasing the carbon dioxide in our atmosphere.
That's what you meant by parabola coming back down.
Yeah.
Do you have the overall ppm, the graph of carbon dioxide in the atmosphere? Did you have
I
that?
should.
I think you have it, right?
Can you pass? So this is my table for Snowfall, not what you asked for, but continue. So the carbon dioxide table actually ends up taking up 2 slides because it's that much space.
Yeah.
But so we have, this is February, January, and then up until December. And so this is the second half of it. The totals, I do have it. I updated this table, but I didn't put it in the presentation. But they do exist.
So since 1960,
1992.
I know, but just looking back, because you look back and I mean, you saw I saw you had the graph of CO2 since 1960. Has it been linear?
It looked exponential, but that was including all of the months. I sort of did it by month, not all at once. So within, this is actually really interesting. So within, if you looked at the graph at a Mauna Loa, it looks exponential, but it's really like toothy kind of. And I sort of, instead of connecting those months, I connected like all the Januaries together and all the Februarys.
Yeah,
together.
that was on, could we go back to that slide?
So, like, this is January, but in terms of, like, the way Mauna Loa sets it up, it'd be like, this is 1992 for January, but then February would be right here, and then like March, and then April, and then it'd be like this,
Yes.
and it'd start going, I could draw this.
Yeah.
So, not drawn to scale, but so, yeah, you can see. So January might be right here, and then February, and then so on and so forth, and then it just like, each high would get a little higher, and then they do this. And overall, so this is like if you zoom in on it, but overall it would look exponential. What I did is instead of connecting each like month to the previous and the next month, I went from January to January, from February to February, from April to from March to March. So
So
I
where
took
on that
the,
curve are you, the curve there that you said is exponential, where are
yes.
you investigating?
I took from this is from 1960 to
Yeah.
the present day, so I kind of went from here to here, and I looked at points that connect to each other, like months that are the same.
So Sue's question is the future, that if you take this linear plot that you have,
It's
what would that
probably
look relative to the graph that you have there?
like this, whereas the sort of overall picture of the year might continuously be getting larger and larger and larger. Yeah. I think it's counterintuitive, or not counterintuitive, but like
So you're not suggesting that
confusing.
February's or January's from here on out are gonna follow this blue line, are you?
No, because this is zooming in of an odd exponential graph. Like I don't know how to think about it because it's really 2D. It's not perfect. It's more like that.
So maybe not every February would follow that, but combined, all the Februarys in the future may follow that line.
Right.
Is that what you're saying?
Good questions?
Thanks.